Okay. All right, so we're going to start Unit 7. And so today we're going to look at ratios and proportions. I don't want to hear any of that. So we need to know the difference between a rate and a ratio. So we're going to start with a ratio. A ratio compares two numbers with the same unit of measure. So it might be, apples to apples, days to days, teacher to teacher, words to words. Whatever you're comparing, they have the same unit. So an example might look like 42 days are to 5 days. Don't your days cancel out? They act like variables. So if that were just a D, 42D over 5D, wouldn't the D's cancel? Yeah. So the days cancel as well. And it ends up just being a ratio of 42 to 5. So if you had to reduce that ratio, that's how you would reduce it. The numbers don't reduce. You're not going to turn it into a decimal. Ratios are always, always fractions. Try this one. 15 gallons to 20 gallons. Bless you. When you reduce it, you reduce it. To reduce the units of measure, reduce 15 over 20. Compare your answer to those around you. See what you got. What do we got? 3/4 is correct. So the gallons canceled, and then 5 went into both 15 and 20, 3 and 4 times respectively. All right, so the only other thing you need to know about a ratio is that there are 3 different ways to write a ratio. So isn't that one way? Yeah. So a fraction, so we're going to do the fraction 3:4. So that's one way. Anybody know a second way? Caleb? 3, semicolon 4. And a third way? Haley? 3 with the word 2 and 4. So these are your 3 ways to write it. So note to self, there are 3 ways to write a ratio. That's really all there is for ratio. How's a rate different? We're going to look at rate next. How do you think a rate is different from a ratio? Anybody give me an example of a rate? Okay. But give me an actual example. How so? We could use a percent to express that, and we'll look at that in later.
Isn't it the slope, so like miles per hour?
Okay, miles per hour is a very common rate. miles per, right, hour. What else? There's more than just that. All your hands went down after that. Is that the only rate you know?
Yeah.
What else do you do something for something? What about at the grocery store? What section in the grocery store uses rates?
Prices?
Something per pound. What per pound? Meat per pound or vegetables or fruits per pound, right? So like you might have, bananas might read 49 cents per pound. That's not what you pay for the bananas. You actually pay more than 49 cents because you're probably buying more than a pound of bananas, right? All right, so that you will usually see in a rate. So a rate also compares two numbers. Right, don't talk. But unlike the ratio, the rate has two different units of measure. So an example might be 82 words per 4 minutes. Now all of the rates that you gave me, miles per hour. So an example would be out here on Greenway. Isn't it 40 miles per hour for part of Greenway? Part of it's 45. But it's 45 miles per how many hours? 1 hour. When you buy the bananas, and I said it was 49 cents per pound. How many pounds? 1 pound. So when you reduce a rate, your denominator has to be 1 unit. So sometimes for rates, you're going to see a decimal in there. So for this one, the words in the minutes don't cancel, right? Mm-hmm. Does 4 go evenly into 8? Or is it 82? Sorry. No. So we're going to take 82. And we're going to divide it by 4. Right? Mm-hmm. So 4 does go into 8 evenly how many times? 2. So 4 times 2 is what? So then subtract 8. I get 0. What do I do now? Nope, bring down that 2, right? So bring down the 2. Does 4 go into 2? Nope. So it goes in there 0 times, right? So I need to add a decimal point, and I'm going to add a couple zeros. So now if I bring down a 0, now 4 can go into 20, right? Yeah. How many times? 5 times. And here's my decimal point. And 4 times 5 is 20. So now I have a remainder of 0. So now I'm done. So then that means that this reduces to 20.5 words per minute, or you can write it 20.5 words / minute. We've seen it written that way, right? Either one of these are acceptable. So a ratio, you're not going to get a decimal, whereas a rate, you might. What about this one? 37 students per 1 teacher. Can that be reduced? No, because I've already got 1 teacher in the denominator, right? So if I gave you something like that, your answer would be, well, it's already fully simplified. So there's nothing I could do to this one. How about this one? $2.42 per dozen. Is dozen a unit of measure?
But it's 1 dozen.
12, but what if I wanted it per item? Because you're at the grocery store, what if you only wanted 1 item? And you wanted to compare this price to another price? Maybe the other item that you're comparing, it doesn't sell in dozens, it sells per 5. Would you be able to compare a price that's per dozen to a price that's per 5? No. So in this case, although this is a fully reduced rate, you could look at that as a fully reduced rate. If I wanted to compare that price to something else, I need to find out how much each is. So how am I going to figure out how much each is? This is really $2.42 divided by 12, isn't it?
Yeah.
So 2.42 divided by 12. You need to bring your decimal point straight up. Does 12 go into 2? No. So 0 times. Does 12 go into 24? Twice. What's 2 times 12? So subtract 24. I get 0. Bring down the 2. Does 12 go into 2? No. So then, and bear in mind, isn't this going to be cents?
Yeah.
I have to go out to at least 3 decimal places because I need to know whether it rounds up or stays the same. So I am going to add a 0 or 2. So I can now bring down a 0. Does 12 go into 20? How many times? Once. So subtract 12. What do you get? 8. Bring down the 0. Right? How many times does 12 go into 80? 6. What's 12 times 6? Oh, yes, thank you. Oh, aren't you smart? Good girl. 2, 0. So then I could have stopped, right? This is a 0. We'll go with that as being 6, right? All right, so I've got it out to 4 decimal places, right? So how much is it per dozen in terms of cents? Because if I want to cut it off to here, right here, what's next door? A 1. Because a 1's next door, we're going to keep it at 20 cents. What if the 6 had been next door? It would have been 21 cents if the 6 had been next door, right? So it's 5. If it's 5 or higher, you round up. If it's below 5, you keep it the same. I don't know, I'd have to see. You're left with 72.8. Yeah, the 6 will repeat. So we end up saying that it is, you can either say it's 0.2 each or 20 cents each, right? So if I have to compare prices, I need to see what the price is per item. And some of your questions on your homework might have that. All right, so can I flip that? Or take it away, I guess. Take it away. All right, example 1. Those were just illustrations. Try this on your own now. Write each ratio. Or rate in simplest form. I don't know why this seems so close today. And so here's your first question on this one. This is 42 days per 7 days. And then B is $1.99 per dozen. So you have 2 problems that you have examples just like this. So simplify them and then check your answers with those around you. When you get your answers, share it with those around you. So share your answers with those around you, see if y'all agree. Talk, talk, talk. If you don't agree, let's figure out who's right, who's wrong.
Would you get for the days?
What'd you get, Miriam?
17.
For the days?
But don't just write 17.
Would you get for the days?
There needs to be a word with it. Or per something. Right?
And what did you get for the days?
How did you write your answer to A?
7.
A?
6/1, 6:6:1 and 6:2.
I gave you A for a very good reason. Look at my answer to A. Do I normally let you write things over 1? With a ratio, it has to be written in fraction form, or, because remember your other 3 forms, or your other 2 forms. If I'm going to write this with a colon, I'd have 6 colon, and then if you didn't write it over 1, you'd have nothing there, right? So it'd be 6:1 or 6:2:1. With the fractions, this is the only time I'll insist that you must write 1 as the denominator, if it's a ratio. Otherwise, we don't. But this is your one exception. So write a star there, and say, and if you didn't put the 1 there, make sure that you put a 1 there. Because you'll get marked points off if you forget that. All right, what'd you get for B?
17 cents.
You have to either write it this, or you could say per item instead of each. Or you have to write it this way, or per item, right? So somehow you have to attach dollars or cents to that. And you have to have a word that goes with it, either each or per item. All right, so that's not so bad, right? All right, let's look at a different situation. So note to self.
And I read it, that's myself, I feel like
Yeah, you are. You're talking to yourself. Sometimes a problem appears to be a rate when it's really a ratio. And I'll show you what I mean in a minute. You ready for your example? All right, so example A, 25 minutes per 3 hours. That looks like 2 different units of measure, doesn't it? But can't you convert minutes to hours or hours to minutes? Okay. And because of that, I'll be able to get my hours and minutes to cancel out. What is the conversion for, well, unless you know, how many minutes are in an hour?
60.
Okay. What do you mean it's not 100?
It's not 100, it goes to 60.
What would have been 100
Simplify
though?
the same, right?
The same as what?
It's like 200, because 69 is gonna
I'm not sure what you're saying, but
So you'd have to put it over 108.
108?
108,
Why?
yeah.
Oh, I see what you're saying. Okay. You could do it that way. I'm going to do it quicker. Yes.
Wouldn't you even have to multiply the 3 hours by 61 minutes?
Well, here's our conversion rate, right? Wouldn't you agree that 60 minutes is exactly equal to 1 hour? Focus, write this down. Those are equal. So if I multiply this by an equivalent, if I multiply this by 1, have I changed its value? Because this is its value, right? But I want to change how it looks. I'm going to essentially give it a facelift. So I'm going to take this conversion rate, and I can either put 60 minutes over 1 hour, or I can put 1 hour over 60 minutes. Which one is going to get my units of measure to cancel out? If I put minutes over hours, will they be diagonal to each other? Could I cancel them out? No. So whatever look at your minutes. I want that diagonal, so I would put the 60 minutes in the bottom. That leaves the 1 hour, bless you, up top.
So is this the proportion?
This is not the proportion yet. Proportion are two equal fractions. What I'm doing is I am using, and again, this is a ratio. So I'm using another ratio against a ratio in order to create a actual ratio. So don't your hours cancel out? And don't your minutes cancel out? What else can cancel? What cancels with 25 and 60? 5. So 5 goes into 25 5 times and into 60. 5 goes into 6 once, with 1 left over. 5 goes into 10 twice. Isn't 5 times 12 60? Okay. So then multiply straight across. I've got 5 times essentially 1, so I have a 5. What's 3 times 12?
36.
So 25 minutes to 3 hours is the ratio of 5 to 36. Right? That's what that reduces down to. So sometimes you're going to have to use conversions. For instance, what would be the conversion to 3 feet? 3 feet equals, 3 feet equals 1 yard. 1 foot equals, listen, 1 foot equals 12 inches. How many seconds are in 1 minute? 60 seconds. Are you listening, Ryan? How many days in a week?
7.
7 days equals 1 week. How many hours in a day? 24 hours to 1 day. How many feet in a mile?
Something.
Close? There you go. 5,280 feet equal 1 mile. You might want to write that down. Now you do have a red Algebra 1 book. I believe they're in the back cover. There are conversions on there. If not, you're going to have to look them up. Also, here's another thing to help you out. Here is Gallon Man. My favorite guy. Gallon Man. He's great. So here is his body. His body is 1 gallon. How many quarts are in a gallon? Oh, that's perfect for our arms and our legs. So this is 1 quart, 1 quart, 1 quart, and 1 quart. So there are 4 quarts in 1 gallon, right? Mm-hmm. Then, how many cups? Well, let's see, no, let's do, how many pints in a quart? Nope. How many pints in a quart? Oh my goodness. 2.
Oh, in a quart.
There are 2 pints. So, put off to here. This is 1 pint. Yeah, he's got weird hands. This is his hands and his feet. So that's a pint. So how many pints are in a gallon? 2, 4, 6, 8. There are 8 pints in 1 gallon. There are 2 pints in 1 quart. You love Gallon Man? You ready for the rest? How many cups are in 1 pint?
A pint?
A pint. How many cups in 1? 2.
2.
So this right here is 1 cup. So that means, that's his fingers. That means that there are 4 cups in a quart, 2 cups in a pint, right? And each of these have 2, have 2, have 2, and have 2. So how many cups are in a gallon?
16.
16. It's very easy to visualize once you know how Gallon Man is set up.
Where's his head?
Now here's his head. There's your Gallon Man. Now, a couple things I'm going to add to this. How many ounces is 1 cup? 1 cup equals how many ounces?
16.
Nope. 8 ounces. Y'all are not bakers.
I said 8.
And then how many ounces in a pound? 1 pound equals 16 ounces.
Oh, yeah. I can put you.
This ounces is liquid measurement ounces. Obviously, if you tried to weigh a cup of water versus a cup of oil, they're going to weigh differently. But in fluid ounces, 1 cup equals 8 ounces. Okay? Alrighty. So that's some stuff that will help you out. If you want to remember what Ryan said, that there are 5,280 feet in a mile, write that down too.
My paper's completely.
All right, you try this one. Oh, well, let's talk about this one. 160 grams to 4 kilograms. Metric system.
3 tens.
Kilo means what? 1,000. So 1 gram equals 1,000 kilograms. Centi means what? Centimeters is 100, right? So there are 100 centimeters in a what?
Where?
In a meter.
What?
100 centimeters in a meter. Kilometer would be 1,000 meters in a kilometer, right?
Oh, is that what grams is?
Grams is different. There's grams, meters, and liters in the metric
No,
system.
I know that.
So grams
Wait.
is
I
weight.
just like skipped over to the.
Yeah, I was like,
King Henry
Grams
died
is weight.
drinking chocolate milk.
There you go.
Okay, so that
I
is
didn't get
this.
that. I didn't hear what she said. What
Say it
she
again.
King Henry died drinking chocolate milk.
said. Oh, I remember that. Mrs. Grover.
Oh no. Is that from?
I learned this from Mrs.
Oh, I
Grover.
learned this in
Okay,
eighth
so
grade
write that down. King Henry died while drinking chocolate milk. We have some more to add to this in a minute. But what's K for?
Kilo.
Kilo. What's H?
Hilo.
Isn't it King Henry died million looking good?
Hecto, right? What's D?
Deca.
How do you spell that? What?
D-E-K, D-E-K,
That's you.
A. Oh, God.
Okay. What's this D for?
Yes.
I know this.
Okay, so what's in between the two?
Centimeter.
Monday looking good.
Monday.
Why Monday?
Yeah, because Monday
Meters,
goes down, it
meters,
goes down.
and grams.
It goes down.
Ah.
So it goes like that.
Well, we have to have meters in here as a unit measure, right? So
Yeah.
here's meters. What was the other?
Meters.
Liters. I'm going to put an L,
Grams.
and then grams. So this is Monday, which is your meters, right? That's your 1 unit of measure, your main unit. And so what's this D? Deci? Because now that's after your decimal point. Isn't this where your decimal point would go after this one? Right? 1 meter. These are 1 meter, 1 liter, 1 gram. So then what's deca? How many meters? 10, because it's 1 over. What's hecto? 100. What's kilo?
1,000.
1,000. You're always moving that decimal point. So this is at 1.0, right along here.
Oh.
And then what's C? Centi.
Wait, what's
And
the-
M? Million. Okay? So then all of these, so you've got hectoliters, kilograms, right? Kiloliters, all that kind of
What is
stuff.
centi? Centi, zero.
Centimeters,
Zero.
centiliters, centigrams.
So what would be inches, centimeters, and liters?
It's
Well, then your
0.001.
decimal point will go backwards this direction, right? So what would be 1 meter as a decimeter?
So it'd be
0.1.
0.1, okay. And then
So there's
0.01.
10 decimeters in 1 meter, aren't there? 100 centimeters in 1 meter, so this would be 0.00, no, 0.01, and this would be 0.001.
Not.
You're confusing me, isn't it 0?
I'm converting 1 into a decimeter.
You just moved the decimal over one.
But really, there's 3 zeros.
All right, so you'd have, if you have 1, wouldn't this be 10, right?
Yes.
How do you convert 1 meter to decimeters? Is 1 meter going to be 10 decimeters?
No. Well, yeah.
Yeah.
No.
And, and won't this be 100, and won't this be 1,000?
Yeah, because it goes opposite.
And then won't this be 0.1?
Yeah,
Because this is a meter. If I'm converting a meter, depends on what you're converting, right?
And then
If I'm
0.1.
converting a meter, this will be 0.1, this will be 0.01, and this will be 0.001. 1 meter is 1/1000th of a kilometer, right?
Yeah, you
Now-
said there were 2
Hang
zeros.
on. What if I've got 5, we'll just call it kilometers. There's my decimal point, right?
Yeah.
5 kilometers.
So then the 50 has to go 500 with the 5,000.
Right?
Decimal.
So as you go along this way, doesn't your decimal move
Yep.
that many directions? So you've got 50, then you have 500. Your meter's gonna end up being how many? Does that make sense? There's a 5,000 meters in 5 kilometers. So then this would be 5,000. Don't put it up there. What's this one?
50,000.
Yep, 500,000. So it depends on where you're at, where you move that decimal point. Right? So if I start here, I move this way. In the blue, I started here at 1 meter. So my decimal point moved 1 to the right here, but 1 to the left here. If I'm here at 50,000 decimeters, my decimal point is going to move to the left 1, so I end up with 5,000, then 500, then 50, then 5. Question?
Is it really spelled with 2 L's?
I can't hear you.
Is it really spelled with 2 L's?
Oh, it's possible. Does that make you feel better? I don't know. I'd have to look it up. I write mm, millimeter, ml, milliliter. I don't really pay attention.
It's a little one.
Okay, so what are we going to do here? How many grams, so here's your grams, how many grams in one, well, let's do 1 kilogram. How many grams are in 1 kilogram? So if you start here at 1 kilogram, how many grams? You're going to move this to the right how many places?
It's about
1, 2, 3. So isn't there 1,000 grams in 1 kilogram? That's how you're going to figure out your conversion. So I'm going to multiply this here. Do I want 1 kilogram over 1,000 grams, or do I want 1,000 grams over 1 kilogram?
1 over 1,000.
I want my kilo up top, don't I, so it can cancel?
Oh,
Or my grams at the bottom. So 1 kilogram is to 1,000 grams.
yeah.
So don't my grams and kilograms cancel?
Yep.
What else cancels?
The 160.
Do you see the 0 on the 160 and the 0 on the 1,000? I can cancel 1 0 for every 0 that's at the end of numbers. Sit up straight in your chairs. Now all I'm reducing is 16 and 100 or 16 with 4. Which would you rather? 16 and 4 would be a lot easier, right?
Yeah.
Then isn't it easy to divide 4 into 100? So 4 goes into 4 once and into 100 25 times. So what do you actually end up with?
1/25.
1 over 25. So these can get difficult if you don't know the conversion for it, right? But here you've had your little mini lecture on your conversion for all of your decimal units of measure, okay? So again, Emily, King,
Henry died drinking chocolate milk.
Monday looking
No,
good.
King Henry died, Monday looking good, drinking chocolate milk.
that way you get your units of measure in there, because kids will forget that.
Yeah.
I have learned it that kids have died over doing, what was it my teacher used to say? Kids have died over doing conversions with
Okay.
metrics, something like that. I like the fact that kids have died over, and I would say doing math. I actually died last night, Mrs. Murray. All right, so can I take that away?
That's all I thought.
Okay, so example, oh, let's look at proportions.
Whenever there's a portion, you tell us what to call.
That's right. All right, here we go. Shh. Focus up here, kids. All right, all a proportion is, thank you, would be 2 equal ratios. And aren't ratios fractions? So a proportion is 2 equal fractions. And then the really big thing, which Emily happened to mention here, is we use cross products to solve. That's huge. You have to know, how do I solve a proportion? Cross products. So example 2. Seems like we've done more than 2. I just want to prove to you that cross products should be equal in a true proportion. So if you've got 4/6 equals 10/15ths, and I ask you, is that a true proportion? Well, first of all, there's nothing I can multiply to 6 to get 15 as far as an integer goes, right? So I can't look at that and say, okay, multiply top and bottom of the same number to get an equivalent fraction. I don't see that here. So instead, you're going to look at the cross products. Doesn't matter which one goes on which side of the equal sign. What is 6 times 10? 60. Is that equal to what's 4 times 15? 60. Don't the cross products equal each other? That's why a true proportion, we use cross products to solve. So if I was missing one of those 4 items, I would just use cross products to find it.
Can't you just reduce 4/6 to 2/3 and then?
Yes, you could do it that way. Good girl. So she said, doesn't 2 divide into both of these? So she said, well, I could divide these by 2 and get 2/3, and then I could multiply 3 by 5 to get 15 and 2 by 5 to get 10. It's a lot quicker to use cross products though.
Wait, but,
And if you're proving to me that it's a true proportion, I want to see cross products.
okay, but what I was saying is, reduce 4/6 to 2/3.
Oh, and reduce the 10/15ths to 2/3 also, yes. Yeah. Yeah, and if you did that, if you reduced both of these to equal fractions, I'd be okay with that. But there are some types of problems where you won't be able to do that. Like, let's say that there's a decimal. You will actually see decimals or fractions within your fractions. So you're going to see some weird things that you normally wouldn't have, but proportions can have decimals in that fraction, or it can have a fraction in a fraction. Yes.
So if you were to reduce that 4 and 6 to 2/3, yeah, 2/3, could you still cross product? If
Yes.
You still have the 10/15?
Yes. It will still work. Yep. Was that your question, Oscar? Did you have your hand up earlier? Oh, I thought you did, sorry. All right, so we're going to solve the following proportions. All right, so A, we've got 4/5 is equal to x over 20. For this type of problem, there's 2 ways you could solve it. What's way 1? Give me one way.
Cross, multiply the 4 and 20.
Okay, so we could use cross products, right?
Yeah.
And by the way, I cannot cancel the 4 into the 20. You cannot, Miriam, please listen. You cannot cross cancel across an equal sign. It only happens if this is multiplication, and it is not, so I cannot reduce the 4 with a 20. What I can do is multiply across, yes. Yeah, I can multiply. So I've got 5 times x is 5x, and what's 4 times 20? 80. So I have 5x is equal to 80. For your note purposes, I put this here so you can figure out, well, where the heck did that 80 come from? So for your notes, you're going to want to write that down. Then how do you solve? One-step equation.
Divide by 5.
Yep, divide by 5.
Yeah.
Can you believe that for many of you that was hard in August? And now look at you. Look at you now. So 8 divided by 5 is 1, 3 left over, and then 5 goes into 36 times. So the answer should be 16, right?
Yep.
And if you put 16 up here and reduce 16/20ths, you do get 4/5. Now here's way 2. Anybody know what way 2 is? Do you see a different way to solve this that does not require cross products? Sure, look at it. Cindy, do you see it?
What? Oh, wait, hold on.
There's another way. Look.
I don't know.
Jesus?
Multiply by the worst.
Nope, can't well, okay. He said multiply by 20 over 1, right? You could do it that way. That's way 3. I didn't even think about that, but yeah, you could. Now, having said that, the reason why I didn't bring that up is what if x is in the denominator? You can't do that. So I don't want you trying to solve a proportion like you would a regular algebra problem, because we can run into problems when the x is in the denominator. Okay. No, you cannot do that. Can I multiply 5 by anything to get 20?
Yeah.
What? So if I have 4 over 5 equals x over 20, sometimes the two numbers that you do have, if they're proportional, whatever I did to this number, I did to this number. So if I multiplied 5 by what to get 20? 4, right? Then I have to multiply the top by 4 because to get equivalent fractions, we multiply top and bottom by the same number. So I could have done it this way, and then I would have had 16 over 20 equals x over 20. So doesn't that mean that x is 16? But sometimes this number is not going to divide into that number. It just so happened on this question that it worked. All right, look at a different one. What if I had 3 over 2x is equal to 6? So Jesus, this is one where I would not want to multiply by the reciprocal because you'll get yourself into trouble. So I don't have a proportion, do I? But can I create one? Put your 6 over 1. Now use your cross products. You're going to multiply the 2x to the 6 and the 3 to the 1. So for note purposes, I want you to write what you did. I did 2x times 6 and then 3 times 1. You don't have to put that in your homework. You can do that part in your head, but for your notes, I want you to write it down. What's 2x times 6? 12x equals 3 times 1? 3. Now, ignore the right side. What do you do to solve for x? Divide by 12. Show that work to both sides. Absolutely do not do it in your head. What do you get for x? 1/4, right? Some of you, if you looked at what we had done here prior to me putting the red down there, you would have said that x is 4. Do you see how you can make that mistake? No. You could, though, if you wanted to. It's a bit of a pain.
Yeah.
You could plug it in and check and say 1/4 of 2 is what? A half. And you could do cross products and see if those equal. Half of 6 is 3, right? And 3 times 1 is 3. So you can check that way. All right. Last set of problems. I got 2 more for you. Thank you. Haley. All right. And then C. Shh. Then don't talk
What?
because you haven't proven it to me yet.
Okay.
This is what I want you to do is just stop talking. All right. So this time we've got C minus 5 over 4 equals 3 over 2. So these can start to get more complicated, right? Nothing has changed. How do you solve a proportion? Cross product. So we're going to take this times this and this times this. So you have to put the t minus 5 in parentheses. So you got 2 parentheses t minus 5 equals 4 times 3. What do you do with that 2 times t minus 5? Yeah. So we're using some of our algebra skills, right? We're combining those. I get 2 times t is 2t. 2 times negative 5, negative 10 equals what? 12. Multiply 4 times 3, 12. Now you solve that 2-step algebra equation. You can do that, right? Show all your work. What do you get? And again, you can plug that 11 in to see if it checks. Okay, what's 11 minus 5? 6. And you could reduce the 6/4 to 3 halves, and doesn't it equal 3 halves? Or you can do cross products. All right, last one. This time we have 4n plus 5 over 5 equals, and by the way, these 5s cannot cancel. Okay, because it doesn't cancel with a 4. Remember that from way back when? And then we've got 2n plus 7 over 7. And again, the 7s don't cancel. So how are you going to solve? So this time we have to distribute twice, don't we? It doesn't matter which goes on which side. You pick a side. So I'm going to do 5 parentheses 2n plus 7 equals 7 parentheses 4n plus 5. It doesn't matter which of the equal sign these are on. It won't make any difference. You distribute and you solve. share your answer with those around you. It's an interesting answer. Share, share, share. If not, I'll put it on there. Yeah, it is. What'd you get?
Well, this is one.
Zero, we got false. Well, I stopped because I didn't know what you would say here. First of all, when you distribute, did you get 10n plus 35 equals 28n plus 35? You should be attacking the variables first, not the 35s. 10n is smaller, so I subtracted it from both sides. So I got 35 equals 18n plus 35. Then you can subtract the 35s. What happens? You get 0, right? Did you get your variables dropped out somehow? Did you not know what to do here?
No, I was doing 35.
Gotcha. So then when I divide by 18, what's 0 over anything?
0.
0 is our answer. Then if you plug 0 back in, what's 0 times 4 plus 5? What's 5 over 5? 1. What's 0 times 2?
0.
Plus 7? What's 7 over 7? Doesn't 1 equal 1? So it checks.
Shocking.